Okay, we'll do this problem here where our goal is, our directions are to find the derivative, which is the same as the direction saying differentiate. Now, the first step that we want to do is we want to write our radical expressions in terms of an exponent. So for radical p, I'll write that as p to the 1/2, and then simplify even further by multiplying p times p to the 1/2 and getting p to the 3/2. I'm using the rule that x to the m times x to the n is equal to x to the m plus n. Now, for this problem, we're all ready to go. I'm going to use the product rule. So we'll use the product rule here because we have two functions here, e to the p times a polynomial, so that's a product. Use the product rule. And I'm first going to have like a little outline of the product rule, where what I do is I take a derivative of the first factor, and then I leave the other factor by itself without taking the derivative. Then I leave the first factor alone and take the derivative of the second factor. Now we're going to use that, so these are the things we're going to use here. So we use that, we already have one thing that I'm showing. The other piece that I'm going to use is that the derivative of e to the x is e to the x. Here are the variables p. The derivative e to the p is e to the p. Looks sort of like nothing was done there, but it was. We took the derivative e to the p, it's e to the p. Now I come to this other, I copy everything else down, but I come to this other piece where I have to take the derivative. The derivative p is 1, and then for p to the 3/2, I have 3/2. So I take that power, bring it to the front, and then I have p to the 3/2 minus 1. 3 to the 3/2, p to the 3/2 minus 1 is p to the 1/2. There we are. That's it. I bet if I looked up on the back of the book that e to the p has been factored out, so I'm going to go along with that. I'll have p plus p to the 3/2 plus 1 plus 3/2 p to the 1/2. Maybe even better is to put those in descending order, power of p, but that's really starts getting to be icing on the cake. I mean, it's essentially done, but I'll just do that. I'll write the highest degree term first, then p to the 1. So I think that looks okay. Try to be neat. All right, that's an example where we use the product rule to find the derivative. Let me just zoom out a little bit so you get the whole thing right there. Okay, so that's all.